Hi guys, this is the video for Chapter 7, Lesson 5. Okay, so previously we had talked about using the percent proportion, which really went something like this. It was the part compared to the total is equivalent to the percent out of 100. So in this lesson, we're going to actually turn this equation into a different type of equation, but it's essentially saying the same thing. And so what we're going to look at today is that we know that this percent out of 100, if I were to say, let's say, if I were to say that 25% out of 100, we could also describe it as 0.25, right? If you turned 25 over 100 into a decimal, it would be 0.25. So we are really just rearranging this equation to say that the part is always equal to the decimal. Maybe I'll write that as a word. The percent as a decimal times the total. So for example, if I wanted to find out what was 20% of, what was 25% of 53, for example, then what I could say is, well, what is the part, question mark, what's the part of 25%, so I'm going to write the percent as a decimal, times the total. I'm looking at out of 53, okay? So I could literally just plug this in my calculator, 0.25 times 53. And I would get an answer of 13.25. And so 13.25, that's the part. So if I wanted to describe it as a fraction, 13.25 out of 53 is 25%. So in this situation, in this example that I'm showing you guys with this equation here, in some way, there's less work that we have to do because our equation, although really means the same thing, it's the same idea as what we have up here. This equation, we're using proportions and we have to cross multiply to find our missing part. Whereas in this case, the equation is just written out here where we can just multiply once and find our answer. So that's what we're going to take a look at today. On your study guide, there are a few examples. Now, of course, there's a few parts to these types of questions, right? Let's write this on your study guide. The part equals 0 point something something. So I'm going to just put an example there. This would be the percent as a decimal times the total every time. So what you have to do is figure out what's given to you. This says find 22% of 95. Now, last time we talked about of the number really means the denominator, and that really means the total that we're looking at. So in this case, this is just like the information that I used in our example, or just like the same type of problem as I did on the example on the other page there. But we're turning 22% into a decimal, so it's 0.22 times 95. You can plug this in your calculator, and the answer is 20.9. So if I were to turn this into a fraction, I would say 20.9 out of 95 is 22%. That's really what you're describing here. Okay. B, it says 15 is what percent of 75? So in this case, really what we're looking for is, well, 15 is what percent? That means we don't know what the percentage is, but we have the part and we have the total. Using this model here, we'll just plug in the information as it's given to us. Well, I have 15, so that's going to go in the section where it says part. I have 75, that's going to go in the section where it says total. And then I can work this out by dividing on both sides. So really 15 divided by 75 is the percent as a decimal. So when I divide it, 15 divided by 75, that equals 0.2. Now, this is not a percentage yet. We've got to turn this into a percentage by moving our decimal 2 over. And so 20% is 15 out of 75 is 20%. So if you wanted to jump ahead and really turn this into the part out of the total is equal to the percent as a decimal, you could do that. I'm fine with you jumping ahead and solving it this way if you'd like to. You just do 15 divided by 75 equals 0.2 and then multiply by 100 to make that a percentage. So example C, 90 is 20% of what number? So in this case, we're missing the total because it says of what number, right? We're missing that total. And so we're going to plug in the information as it's given to us. The part is 90. 20% is written as 0.2. And then what number, I don't know. So I'm going to put a variable there. I can divide both sides by 0.2. So divide by 0.2 on both sides to cancel it out over here. And I'm left with my unknown. So 90 divided by 0.2 is 450. And so 490 out of 450 is 20%. So if you wanted to like double check that, 90 out of 450, you can divide those and that would be 0.2. And that means that's 20%. Okay. So let's pick a few of these and work them out. I'm going to just do a few problems that go over these types of examples, maybe 2 of each, but I'm not going to do every single one here. Okay. So I would say, why don't you guys try it? So I'm going to I'm trying to look for different examples. So we're going to do these 6. You can pause and work these out. See if you can figure out what the answer is. I will write the equation. I want you to write the equation of your work. You have to write the equation. Even though you can just plug it in your calculator, it is important, especially on your homework, that you write out the equation because that's where I'm seeing where your thought process is coming from. So I can understand either you're getting it, it's making sense, you can turn this, your thoughts, your abstract thinking into concrete sentences using math sentences, right? Or not, right? That's where I see it. So make sure you write out the equations. Okay, so I'm going to work these out. Okay, So I've done the first two here. If you wanted to double check your answers, you could literally put your part out of your total, divide that, and see if you get the percentage as a decimal. I'm going to pause these and work the rest of the four out, and then play this again for you guys. Okay, so let's take a look at our answers here. I wrote out the equations on the side. If you want to pause and check your answers, you sure can. I didn't show my work in terms of dividing on both sides. You can show that, you cannot, it's up to you. But I do want to talk through that I basically did 39 divided by 240 to get 0.15. Now in the ones where it asks for the percent, please make sure that you turn your decimal back into a percentage. So in this one, my decimal is 0.995. To make it a percentage, I'm going to move over 2 times to the right, bring my decimal where it belongs, and my percentage becomes 99.5%. So make sure you move that decimal 2 over to the right, and then just round to the nearest tenth if you need to after you've turned it into a percentage. All right, let's take a look at the back. So what we're doing here is taking a look at real world problems and using the same equation to find out our answer. So what we need to decide when we're reading the problem is what's our part, what's our total, and what is our percentage. So let's look at number 1 together. Emily is training for a marathon. She ran 4 miles every day this week. She wants to increase her distance every week by 25%. How many miles a day will she run next week? Okay, so we've got to decide, what does 4 represent and what does 25% represent? 25% represents that's where our decimal would go, right? We could just turn that as 0.25. So that one's pretty easy. So the question is saying she wants to increase her distance every week, so previous week, by 25%. So we're looking at 25% of 4. And so what we're looking at is what is 25% of 4? Now 25% of 4, if you work this out, or a quarter of 4 is just 1, right? So what this means is that she needs to increase her next week's miles by 1. And so if the question is saying how many miles a day will she run next week, well, she's increasing what she ran previously by 25%. So we're going to add her previous amount of miles to the 25% of what she ran. So it would be 4 plus 1. So this next week, she would have to run 4 miles. This question was a little trickier to kind of think through and talk about what was going on with all these parts, because we kind of had to add that answer to what she had previously. Okay, so let's take a look at number 2. Juan got 15 questions correct on his pretest. He wants to get 20% more correct on his post-test. So this is a keyword, more. That really should hint to you that there is some addition involved, okay? How many questions does he want to get correct on his post-test? So this is the same idea here. We're looking at 20% of what he got on his pretest, and we're going to add that to what he got correct on his pretest. So we're going to look at this as 0.0 or 0.2, 20% is 0.2 times 15. So you can just plug that in, 0.2 times 15, and that's 3. So x equals 3. That doesn't mean he wants to get 3 questions correct on his post-test. It means he wants to get 3 more correct on his post-test. So that means we're going to do 15, what he got on his pretest, plus 3, and that's going to be 18. So he wants to get 18 questions correct on his post-test. Does that make sense? Okay, next question. The average person should eat around 2,000 calories a day. If Susan ate 1,500 calories, what percent of the average person's total did she eat? So what we're going to do is to look at what our part is. I think that's 1,500. What's our percent? We actually don't know that. And the total that each person should eat is 2,000. So we're going to do 1,500 divide by 2,000, and that's 70.75. And that means she basically ate already. She is eating 75% of an average person's total amount of calories per day. Okay, number 4. Chan bought a $600 computer, but his total was $648. What percent sales tax did he pay? Okay, so this one is asking, out of the amount that he's paying, what percentage is the sales tax? So before we calculate this, even though here it says that his total is 648, what we're looking for is what percent of sales tax did he pay? So there's 2 ways of doing this, and I'll talk you through how we could do this. The first way is by thinking through, okay, how much of this money was the sales tax? Well, if the cost was $600, we could do 648 minus 600, and that would be 48. So the part that's the sales tax is 48, and we don't know the percentage. We know the total cost of his computer is 600. So that means we're asking what percent of 600 equals the tax that he's paying. So we could do 48 divided by 600, and the answer is 0.08, which means that he's paying about an 8% sales tax, okay? The other way of doing this is to say, okay, the part that he's paying is 600. We don't know what the percentage is, and the total that he's paying is 648. Now, when we do this, though, you're going to find something interesting. 648 is, it ends up being a really big number. It really becomes, you've got x equals 0.9259. So in other words, this is like 926, maybe, something like that. So the cost, basically the cost of his computer out of the total that he's paying about 92.6%. 92.6%, which means the rest of the cost that's remaining, he's paying 92.6%. The rest of the cost is the tax, is the rest of the percentage is the tax. So we can do 100 minus 92.6, and that gives us about 7.4% that he's paying is the sales tax. So I don't know if the second way makes sense, but I would recommend probably the first way of doing it. But in this case, you kind of have to think through, well, what are we looking for the percentage of? Well, we're looking for the percent of tax. So it says it here, percent sales tax. So you have to calculate what's the amount of tax that he has to pay. Okay, and here I know the answers aren't quite completely the same. This is 7.4%, this is 8%. So there's a little bit of variation there. Number 5, Jody found a pair of jeans on sale for $90. Her friend told her that they were only 75% off the original price. Okay, what was the original price of the jeans? Man, these are expensive jeans. So that means 90 is the part, and 75% is the percentage, and we want to know how much those jeans cost originally. And so when we work this out, divide by 0.75, it was $120. So her jeans were $120 before the sale. Crazy. Those are expensive. And that's all I have for you. If you have any questions, just let me know, but that's all.